Hi there, I'm going to tape a video right now on how to factor. Now, if you look on the front page of your factor packet, it says it's a factoring flowchart, and these are kind of just things that you can do that will give you an idea of what you need to be doing. So if I have a binomial or something with two terms, such as 4a squared minus 9. This would be the difference of two squares, because 4a squared, the square root of that is 2a, and the square root of 9 is 3. So those are both perfect squares. Now we also have a situation also where we can have the sum or difference of two cubes. And in this case, this is x cubed minus 27, or x cubed plus 8, where the cube root of x cubed is x, and the cube root of 27 is 3, and then the cube root of x cubed is 3, and x, and the cube root of 8 is 2. So when we're in these situations, though, we have a couple of formulas, and I will write these down as we're working through the problems, but they're found on the front of your page. So looking at the back of the first page are all sorts of different examples of the different types of problems you will see. So the first type of problem you may see is when you have terms and they have a greatest common factor. And so I can factor out a greatest common factor from each of the terms. And in this case, my greatest common factor is 12. And so I take 12x squared and I divide it by 12, and that's x squared. And then I take 24 and divide it by 12, and that's 2. So I'm left with 12 times x squared plus 2, and I can't factor that any further. The next type of situation is when I have a squared minus b squared. And in this, you can look on the front of the page, and it factors to a minus b times a plus b. And in this case, I take the square root of 9g squared, so a is 3g. And then the square root of 49, b is going to be 7. So I have 3g plus 7 times 3g minus 7. And you can put them in any order because of the commutative property of multiplication. The next is the difference of two cubes. Now in this case, the cube root of a cubed is a, and the cube root of 8 is going to be 2. And I have the difference, so I use the formula for the difference. And that is a minus b times the quantity a squared plus a times b plus b squared. And so that's the formula I use. And now that I have a and b, I just plug it in. So I have a minus 2 times a squared plus 2a plus 4, because 2 squared is 4. And then I factored that as far as I can factor it. The next situation is the sum of two cubes. And in this situation, I have a formula that can be found on the front of the page. And it's a cubed plus b cubed, so that's a plus b, times a squared minus 2a plus b squared. And that's just the formula that you're given. Now in this case, a is going to equal a, and b is going to equal 3, because 3 cubed is 27. So I have a plus b, I have a plus 3 times a squared minus, this is not minus 2a, that would be times a times b, so times minus 3a plus 9. So again, I apologize, that's a times b. And you can look at the formula at the front of the sheet, and so that is your final answer. Now the next situation is when I have three terms and the coefficient of the leading term is 1. So in this case, I can just do the x factor. And the x factor means I do a times c in my top x, and then 5 in my bottom, which is right here. And I have to ask myself what two factors of negative 14 can be added together to equal 5. And so those are 7 and 2. So then I have b plus 7 times b minus 2. And that is my final answer. The next thing, I have three terms down here, but my leading coefficient is not 1. So I do the x factor, but then do the bottoms up type thing. So I have a times c, which is negative 40, which is negative 5 times 8. And then my b is negative 18, So what two factors of 40 can I add together to get negative 18? And that would be negative 20 and positive 2. Now in this case, my leading coefficient is an 8. And so I'm just going to add that x there because that helps me, like we talked about in class. And then I simplify these. 4x over 1 and 2x divided by over negative 5. I've divided by 4 for each of these. So I'm left with the two binomials, 2x minus 5 quantity times 4x plus 1. And I'm done. I've factored my two binomials. The next thing that we talked about today in class is grouping. And so I group my first two terms and see that my common factor is r squared. And so when I divide r cubed divided by r squared, I'm left with r. And then 3r squared divided by r squared, I'm left with 3. And the same thing over here, I see what's common between 12r and 36, and it's a positive 12. And when I factor it out, I'm left with r plus 3. Then I see that both of my terms have an r plus 3, so I can factor those out. And then I'm left with r squared plus 12. So that kind of finishes up all different things. And then you can look at this one below and you can factor out the greatest common factor. So hopefully that'll help you study.